This is Anita Wood, and welcome to this topic snippet video where we introduce objects. We're going to take our class template that we've been talking about and learn how we can now use them. Let's review what we know so far about classes. A class is a blueprint for an object, quotes, that we wish to emulate in our software. In the software, that we use them to create a software entity called object, unquoted. Ultimately, the class provides definitions for the attributes and methods all the objects we are going to need to create in our code will have. So here's a UML diagram for our simple rectangle example. The top portion of the UML diagram shows the two attributes or fields every rectangle in our program must have. They are length and width. In the bottom portion, there's the definition for the methods or behaviors our rectangle will need. The first four are the setters and getters for the attributes. We discussed setters and getters in the previous video. As a quick review, because the attributes are declared as private, meaning code from the outside class cannot access them, we need methods that will allow access to these attributes. The setters and getters are called, for example, to set a value in a particular attribute, and the getter will retrieve the value from an attribute. The setters and getters are public, so the code outside the class can call them. The final method is calculate area. This is an action that we wish every rectangle we define to be able to accomplish. It too is public because we need code from the outside the class to be able to call this method. Remember, the area of a rectangle is its length times its width. So here is the Java code we created for the rectangle class. The previous video discusses this code in detail. I'm presenting it here so we have it to reference when we start creating objects from it. Our rectangle class is ready to go. Now, let's use it in an application. Let's say we want to build a pool in our backyard. First thing we must consider is how much space is needed to build the pool we're thinking about, and is our yard big enough? Second, we also need to consider the area of the pool because our property insurance will increase by adding the pool. The increase in the insurance is calculated using the area. The bigger the pool, the bigger the increase. We talked about the term instantiation in the Intro to Object-Oriented Programming. We're now going to go into more details about what it means and how we do it with code. So, to create a reusable version of our class in code, we must first instantiate the object. Instantiation is where we create an instance of the class in our code. It is the instance that we directly manipulate in our application. So here we create an instance of rectangle class and call it my pool. The code here is the Java code needed to create an instance of the rectangle class called my pool. If you look closely, you'll see the left side of the equal sign looks like a variable definition. But instead of declaring my pool to be an integer or a string, we're declaring it to be of type rectangle. So you can think of rectangle as a user-defined data type. We define the type of data that the rectangle uses. From our previous discussion on variables, we know that when you declare a variable, you're setting up space in memory which is going to hold the value of that variable. The same thing happens here. Memory will be set aside for the variable my pool, but it doesn't contain a single value. Think about this a minute. The memory location cannot contain just a value of the instance my pool. My pool has in it the attributes length and width, as well as the setters, getters, and calculate area methods. So what is saved in memory for the value of pool? What it is, it's a memory location that points to another area in memory that contains all the stuff we need for the instance. The stuff being the attributes and methods. So now we can interpret the left side of the equal sign. What's going on with the stuff on the right side? Back to what we know about declaring variables. We're able to not only declare the data type for the variable, but also provide it with an initial value. Here, we assign the variable x to the initial value 10. The right side of our class initialization statement looks a bit more complicated than our simple declare and initialize the variable x. That's okay. We're going to pick it apart piece by piece, and it'll make sense. First, there is the keyword new here. I'm calling the new keyword an initialize operator because our instance variable has only a memory address that points to another location in memory, which will ultimately hold the specific values of our instance. It's obvious that there's more work to be done here than the normal initialize our x variable to 10. So the new keyword signals the fact that more work is needed. When you take another course on object-oriented programming like Java or C#, you will learn even more information about this new operator. For now, that's all we need to know. Next, we have a call to the constructor for the instance. A constructor is a special method that's called, and it will set the various attributes in memory. Here, rectangle followed by the parentheses signals it's a method call, and the method is calling the constructor method for the instance using the rectangle class. Like all methods, you can pass arguments to the constructor. Many times, these arguments are the initial values for the attributes in the instance. Notice here, we're not passing any arguments, so no values are going to be assigned to those attributes. Let's look back at the memory to check that out. Looking at the memory set aside for the myPool instance, you'll find length and width are set to 0. Well, 0 is the default values Java puts in memory for attributes if they're not given values in the constructor. So as I said, there is more to come regarding constructors in the later video. For now, just understand this is the Java code that will declare and initialize an instance of our rectangle object. This is the Java code, shows the complete code for our Design a Pool project. Here you can see where we added the code to instantiate our pool instance from the rectangle class. I placed it after other variables that I'm going to need for the program, like area. Right now, the values for the length and width of our pool, as we said, are 0. So how do we go about putting in the actual values for my pool? We do this by calling the setter methods that we designed in the class. To be able to call the setter method specific to my pool, we have to use something called dot notation. Dot notation uses the dot operator, or the period, to denote which method we wish to call in a particular instance. Here we see the code set to call the setter for the length and width attributes in our pool instance. The instance myPool is first, followed by the dot operator, and then the name of the method and its arguments. The setLength method has one integer argument that is used to set the private length attribute in the instance. Same goes for setWidth. After these two statements are executed, the memory for the myPool instance will look like this. Now, it's time to determine the area for the pool. We call the instance method calculate area, which returns the value for the area. We're storing this value in the area needed variable so we can print it out in the next statement. Remember in the introduction to object-oriented programming video, we showed how you can use the class definition more than once to create more than one instance. In that video, we were calculating your age or your friend's age. Here is both the Java code for the age class and the main method. The box indicates how we define two instances of the age class, one for you and one for your friend. We distinguish between the two instances by using two different names, your age and friend age. You should now have a better understanding of how Java keeps track of which instance to reference when calling a method for the instances. The dot notation syntax makes sure you reference the correct instance method by calling a method. So the various colored lines here show the resulting input and printing that happens for each instance. Green line for your age and red line for your friend's age. This concludes the topic snippet on creating an object from a class in OOP.